will be shared later with additional people. Today, we're going to speak about how we manage the automotive cybersecurity risks, how do we manage them, and most important, how we optimize this. My name is Gilad Bandel, and I serve as VP Cybersecurity at System Weaver. So let's go over the agenda and items that we want to discuss today. First, we're going to speak about the challenge because every lecture starts with the challenge. Then I will relate to an article that I wrote before, and I'll bring here a brief of that article that speaks about the pillars of the risk management. So this session, this lecture is based on that previous article. So I'm going to relate to it and bring the major items from there so we can carry on to the more advanced optimization stuff. Then the focus will be risk management optimization methods. We're going to see quite a few methods how we can optimize. I'm going to propose a method how to implement this and how to make practical use in organization, and we will summarize. Important thing to notice, although we're speaking automotive cybersecurity and then speaking about specifics of automotive cybersecurity, the same concepts and principles can be applied to other industries as well. So if by any chance you're in the OT, IC, SCADA, or in the IT or maritime, or the same concept would apply, but you would need to find the specifics of that industry and take the same principles and apply to there. So let's look at the challenge. There are actually many challenges, many reasons why today's risk management is not optimized. Just to mention a few, many organizations are compliance focused. So what they care is to get their certification and say that they comply with the standard of the regulation. And from there on, they carry on. So they don't care about the real value of the cybersecurity. The second reason that we can count is that organizations tend to be silo-oriented. So tools are disconnected and there is no synergy between those tools. So information is not used from one area in another area. So this brings us to a situation in which you might have the information in your organization, but the fact that it does not flow to the right place, and it does not influence, you lose money. Vulnerabilities, major item that we're going to discuss today. Usually organization map the vulnerabilities in code, in an image, and prioritize them according to the CVSS security. But it is totally irrespective of the contextual considerations. Let me give you an example. If you might have a critical vulnerability in your Linux that has to do with the floppy disk driver, I can assure you 100% nobody is driving a vehicle with a floppy disk. So that's totally irrelevant. And if you go and fix that bug, you're wasting your time and money. Better spend it somewhere else. Threat intelligence. Yes, people learn about threat intelligence, but it is not used. So if you have the threat intelligence information, influence the R&D priorities, replace packages which are threatened, which appears a lot in the dark web, and hackers find themselves very interested in those things. So you can just avoid or update or improve. But if you just read the threat intelligence without making use of it in all the places in the industry, in the organization, it's a waste of time and money. Many cases you don't take into consideration financial and commercial consideration. How much does it cost to fix this vulnerability compared to others? How much time does it take to implement a control versus other alternatives? how large is the fleet, and so on. There is a lack of collaboration in organization. People tend to keep their information to themselves in many cases. And there is a lack of and incomplete information sharing. So those are the challenges that our industry is facing. And I'd like to propose methods how to improve this situation. And those should be practical methods. It's not theoretical. Those are things that worked, that I see them implemented in some places, and I see the value. So let's look at the article that I was relating to. You have here a QR code, so you can scan it. You can also search for it in the internet. Those are the pillars that we see in the automotive risk management. You can claim and you can argue that it can be more or less. You can remove one, add one. Yes, I know that there's more than one opinion about it. As I know, every two people have three opinions, so this is a good idea where this can be implemented. So briefly going over those pillars, we look at security requirements and how they are influenced and how we influence the system abstract model. So you cannot do real vulnerability management without seeing the abstract model, because otherwise you are working in the dark. Threat intelligence, how does it influence and how is it influenced, and what is the meaning of adding threat intelligence information to your system model? Penetration testing. You can do penetration testing, but then you need to understand whether the vulnerability or the weakness that you found, is it relevant or not? What does it influence? So finding a penetration test result which shows something doesn't mean actually anything if you don't see it in the full context. Now, next, the vehicle is on the road, and your intrusion detection system reports some findings, some events, some qualified cybersecurity events. Those need to be analyzed, and they need to go through the glasses of the TARA and the whole risk management system. So the VSOC will understand whether this is a real event or just some noise. Many bodies in the organization can enjoy it, and this is about information sharing and synergy. R&D, the risk management group, complies for homologation, the vehicle security operations center, the product security operations center, and I can think about more groups. So you're encouraged to read this article, and this is a basis for the current presentation. In this slide, I just go over the items. So after we share the presentation and the slide and the video, you can go through. Everything here is documented and written. So let's look how a high-level process would look like working and thinking in the method that I propose. So first of all, we need to implement a robust system, making sure the production of the cybersecure and regulation compliant vehicles. This is a very big difference. You can have cybersecure vehicles which are not regulation compliant, and I'm okay with this. Not sure the regulating bodies are, but at least I'm okay with it. From the other side, you can have regulation compliant vehicles which are totally unsecure. So in this case, the surgery was a success, but unfortunately the patient died. In the current situation with the UNR 155 and other regulation, we need to have both a cybersecure vehicle and a regulatory compliant vehicle. And if you go only on regulation, it's quite easy to pass regulation. Currently, the auditing bodies, more or less, they just want to see that you have a process. And if you have a process and show that you have a process, you're good to go. Next, they will ask to show that you actually implement the document and the process, and you have documentation of the implementation. In the next years, They will also ask you to prove that you actually implemented controls, and that later they will ask to show that the controls are effective. So the regulation today is relatively easy. In the coming years, it would be harder, and you need to prove not only that you are following the process, but also that the process is effective, efficient, and it is enforced and incorporated in the vehicle. We spoke about different sources of information, so those need to be fused. The fact that you have a diverse set of sources means that you can check and cross-check and double-check information from different sources. So this gives you a better multi-dimensional view of the risks. It's not flat, it's not a single source, you have multiple sources. We will propose, and I will propose here and outline the method and methodology and guidance how the industry should act and what should be the industry best practice to achieve this effective and efficient risk management. Our target is to steer the industry, and our target is to lead the industry and point the way for the industry. And we hope that the industry will listen, will follow this advice, and will come to a situation in which the whole system and the whole cybersecurity is done in a better fashion. Who would enjoy working this way? So it's with a good purpose. R&D will do a left shift. So the sooner we come with information, the sooner we feed with sources of risk, threats, vulnerabilities, R&D can better plan their work and prevent cases in which they need to redo work, they need to fix things. So it's in the best interest of R&D to be part of this process. The major body that would lead this process is the risk management, because the risk management is the central body which coordinates between all the other bodies. And we hope that the risk management will be the leader of this process. Compliance will enjoy it. You might have a combined risk management and CSMS. You might have a separate system, but coordination and cooperation and synergy between the homologation process and the risk management is vital for the organization. VSOC will enjoy it because information that is fed into the VSOC will go after the filter and after the analysis of the risk management system. So engineers there will focus more on real event and will not be bothered by nuisance and by false positives. And when there is an event, it will come with the full information of the impact and alternatives way to mitigate this event and so on. The product SOC, same as the VSOC, will receive information regarding the product and will be able to manage the risks and the security of the product in a better fashion. And I can think of many other bodies which can enjoy it. Here I want to show a few methods. So I will outline a few sets. For simplicity, I always take a couple, and I will show how two things work together. This is for simplicity reasons, and so the presentation will be easy to understand, but obviously you can go into more complex scenarios. So let me go through those cases. How do you do vulnerabilities with the system abstract model? How you synergize between threat intelligence and the system abstract model? How you synergize between vulnerabilities and threat intelligence, between user stories and the system abstract model, controls and the system abstract model, financial consideration and risk mitigation in light of financial and commercial consideration. And we can think about more, but I think that 6-7 cases would demonstrate my point. So let's look at vulnerabilities and system abstract model. If you work in a silo, then you have the system abstract model, which is built for engineering purposes, and you have a list of vulnerabilities which you prioritize according to their severity. And if you are good enough, you even look at exploitability. So you only address vulnerabilities which are severe, but also are known exploitable use cases. Even though you can claim that you might not be aware of a exposure that is using exploit that is using a vulnerability. What we offer here and what we propose here is to take the binary image, which is the most dependable source of the SBOM and vulnerability detection. In many cases, especially OEMs, but tier ones do not trust the supply chain. So even if you receive a SBOM from your supplier, don't trust it. It might be an addition to your independent SBOM discovery, but definitely not the only source. And if those vulnerabilities are managed only in the context of their vulnerability severity score, you gain very little. It should be in the broader context. For example, the ECU profile or the over vehicle architecture. Let me give you a few examples. If you find one vulnerability in the TCU and the same vulnerability or another vulnerability in the BCM, you better address it on the TCU first in terms of priorities, because that's a connected device. And if it happens on a connected device, chances for a kill chain are much higher than on a device which is somewhere else not connected. Other thing that you can take into consideration is the vehicle topology, which if you do just vulnerability management, you are not aware of. But if you have an ECU, which is behind two secure gateways, and you have another ECU, which is not behind the big gateway, or just behind one gateway, obviously the one that is behind two gateways can be considered safe. So you better allocate your resources focusing on the one which is not behind two gateways. Is it safety critical or not safety critical? If it's the air conditioning or is it the brakes? So looking at the ECU profile, ECU location in the topology, the overall vehicle architecture can enable you to take the vulnerabilities and manage them and prioritize them according to a more realistic and more relevant sorting order than just going to the severity. Let's look at the system abstract model and threat intelligence. So if R&D is working on the work plan according to the abstract model and is developing, that's nice. But you need to look at the threat intelligence and need to provide and feed the threat intelligence information to the R&D. So if you see that in the dark web, hackers find a lot of interest in a specific package or a specific ECU or a specific vendor, you should alert your R&D that something might happen there. And you can take preemptive actions. For example, you can replace a package with an equivalent package that does the same thing. For example, a math package. Even though both of them do not have any known vulnerabilities or are equal in their vulnerabilities, or equivalent at least, but one is not of interest of hackers and the other one is very much in interest of hackers. So this way you can prevent risk, you can reduce risks ahead of time. So merging the R&D process, looking at the system abstract model and threat intelligence will enable generation of better and safer cards. Let's look at vulnerabilities and threat intelligence. So the same idea as with the system model apply here. You took your vulnerabilities, and let's say you are even a good student and implemented the first lesson saying that vulnerabilities are done in context of the vehicle abstract model. But now you take the threat intelligence into consideration and you go over the vulnerabilities and you prioritize them according to information which derives from the threat intelligence. So if there are specific vulnerabilities which are discussed on the dark web, this indicates that hackers are working towards exploiting and finding methods to create a kill chain and use that vulnerabilities as part of the attack surface or part of the attack vector that they're going to use. This is a very good indication what you should prioritize. So if you have the same two vulnerabilities, one of them is of very much interest and appears on the threat intelligence map, and the other one does not, and you have exactly $1 to fix either one, here is your consideration, what you should do. You should go to the threat intelligence information, apply it to the vulnerabilities, prioritize accordingly, and you get a safer car as before. Let's look at user stories and abstract model. So the R&D translate the function requirements to user stories for coding. And the risk management often comes much later in the process. We would very much like to see something that is called SSDLC. SSDLC stands for Secured Software Development Lifecycle, secure by design. So the risk management comes later in the process, and this results in rework and refactoring and additional R&D efforts. Those could have been prevented. So the cybersecurity consideration should be included and considered from day zero. So this is part of the original system design, original stories. So once a user story is drafted, you can automatically analyze it. So you take the user story and feed it through a, now it's nice to say AI and generative, but you go through a Tara process and you analyze the user story. It can be very complex or it can be very simple. So a very complex case would be take the user story, analyze it, and understand what's going on there, and try to derive risks. A simple case is just go by keywords. So if you find the keywords Bluetooth, Wi-Fi, and so on, this is the place where you can implement ahead of time controls even at the level of the user story. So it's way before coding. This way you took the user story, took the abstract model, understand where this thing fits in, according to the analysis, define which controls need to be implemented and include them now in the user story. Now, this thing relates to a bit more complex thing that we're not going to discuss today, has to do with Agile and Tara. Very briefly, the Tara is a V model. One can claim to some extent that it is based on the waterfall model. In any case, iterations are not built in naturally into the Tara. As opposed, the R&D is working in a agile way of work, which iterations is the way of work by default. Now comes in the question, how do you implement Tara in a agile environment? You go to micro Tara, incremental Tara. If you do micro Tara, does it cover the whole story? Many challenges here, but one thing is certain: the earlier you implement controls in the system, in the user story, based on analysis by the Tara, the better the better, the safer, and cheaper the cars will be at the end. So this is the way to implement and synergize between user stories and the system model. Let's look at control and the abstract model. There are cases in which a control is implemented in one place, and then you implement it again in another place and another place and in another place. But if you look at the system abstract model, you can see that the same thing applies in many cases. So you can save a lot of money by implementing it once and duplicating in other places. This way you can choose those controls which create the highest impact. So if the cost of implementing a control is, let's say, $1,000, and one control appears 5 times and another control appears 10 times, you would be better implementing the control that appears 10 times, because for the same money, you get twice the security. If you implement controls blindly, you do the same work again and again, and you do not take into consideration the vehicle architecture and structure, and you cannot leverage on this thing. You can go even one step higher. I'm not speaking about this here, at the OEM and organization level, and think how you can implement this in more than one vehicle. So you might have a few vehicles which are using the same control, and you need to invest the effort once to implement that control, and then you can copy paste and implement it not only in the specific vehicle, but also on other vehicles that are being developed. So this is another consideration that I don't go too much into it due to lack of time. Let's look at financial considerations and risk mitigation that applies to vulnerabilities, equally to controls. How much does it cost to fix something? How much does it cost to implement a control? And what value do you gain out of implementing this control or fixing this vulnerability? It relates a bit to the previous item that I spoke about, but now I'm speaking from the financial point of view. When you plan your work, you need to attach a price tag for each vulnerability and each control that you're going to implement. And you need to see how many times you can use that control or reuse the vulnerability fix in other places. And then you need to weigh what is the value you gain out of this implementation. Based on those things, you can decide what will be the outcome and the value for money that you're going to gain out of this implementation. So it's very important to look at the financial consideration and not only at engineering perspective. And I know that many of us are engineers and care less about money, but the organization does, and it's important to bring economics into the R&D. Last case is a commercial consideration. When we implement a risk mitigation, we need to look at the fleet, organization, vehicle size, and so on. So additional considerations. Since the budget is limited, if we have, let's say, for the sake of simplicity, $1,000, and we can fix one bug in a passenger vehicle or in a heavy vehicle, in a commercial vehicle, given that the damage that can be caused by one truck is much higher than one passenger vehicle, then we're going to invest in the heavy-duty vehicle. Let's say we have a fleet size of 10,000 cars and 100,000 cars. The 100,000 cars is more important than the 10,000 cars. Another consideration might be the brand. So if you are manufacturing sport, high, expensive cars and family cars, and the brand damage due to a bug, a cyber attack on a sports car, it's much higher, then you might want to protect the sports car before the passenger's car. So here come in considerations which are very, very far away from engineering. One should claim that it shouldn't even be mentioned and it shouldn't be a consideration. But we live in a real world, and we have limited budget, and for limited budget, we need to spend it wisely and implement other consideration beyond the direct engineering considerations. We can think about many more synergies and combination of 3 and more synergies components in one scenario, one use case. I think that for today we covered the major ones, and you can take them and use them at home as you see fit, using the same principles and using the same concept for other cases. So just as an example, you can add penetration testing information, which we didn't speak about, IDS information, cybersecurity events, incidents, information from the VSOC, and so on. So this is the basics of what to do. Let's speak about how to do it. So this is a high-level concept of how this system should look like. So if we look at the components, let me move here to technology. So if we take the abstract model and the image, we saw that in the system model, we can synergize. We can take threat intelligence and apply it to vulnerability management information, and we can apply it to the system model and create a data fusion of all this subsystem. We can take penetration testing information and cybersecurity events originating from the IDS, and we can feed it into the whole system management. We can take all the non-engineering related items such as financial, commercial, business factors and feed them as well into the system. The system works and generates an extended system model, threat intelligence, damage scenarios. We can trace goals and claims. We can generate a terror report which takes into consideration all those things. We can prioritize the control and risks according to the consideration that I mentioned before. And we can integrate with other tools that would either feed the system or would benefit from the information of the system. Who enjoys this thing? Everyone. R&D, risk mitigation, compliance, homologation, the vehicle security operations center, the product security operations center, and more. So let's summarize this part and then come with a proposed formula. So optimize risk management process. We take the engineering of the system abstract model and integrate it with security requirements for the Tara. This is a standard process. We feed the asset management, namely the SBOM, and we enhance the system abstract with this information, so we have a lot of asset management information that we can work with. We augment it with vulnerability management output. The identified vulnerabilities are correlated with the abstract model. On top of it, we add threat intelligence, and on top of it, we add the financial and commercial consideration. So this is an example of how we can build a optimized process that would generate a cheaper process, a more effective process, and safer cars. It's not a math lesson, but this is an idea of how to create a formula which takes into consideration all the outputs out of the occurrences of the vulnerability or the control, the attain factor, the threat factor, the cost and commercial factors, all those multiplied by the weight. So every organization might award a different importance to the different components. So one organization might think that threat is more important, another one might consider that cost is more important. This is just an idea of a formula. It needs to be adapted and needs to be customized to each and every organization, policy, and concept. So this is an idea of how to do the formula. Don't run to Excel now and implement it. It needs some thinking. So this just explains the prioritization formula in which we take the different factors and implement them. What are the benefits? R&D will enjoy a left shift and early software security because we do the user stories and look at threats and threat intelligence and create controls ahead of time. So R&D can work less and generate more. The major person that would enjoy it is the risk management, and this is the tool that risk management can dream about. Compliance, VSOC, and PSOC obviously will enjoy. So let me summarize. Our target is to save lives, to reduce injuries and damages. We need one synchronized single source of truth for everyone to use the information. So this means that not every group has their own database. You need to have one central synchronized database that everyone is going to use, both the engineering and risk management and the VSOC, so they can see views of that database and have different abilities to change or update the information. But if every group has its own database, you cannot trust anything. Working with Excel is out of the question. With Excel, you just copy paste information, and if there is an update somewhere, it is not propagated to anywhere else, and then you harm the security and the efficiency of the organization. So for a good system, you need a central database which will serve as a single source of truth for everyone. The knowledge created and the value created will be enhanced by this process. So follow this thing, optimize, and you'll get better results. The risks are not scored in the void, they are scored in context, and in context of as much information as possible, mainly the full system, the function of the ECU, threat intelligence that we have. This will enable you to focus on addressing the real risks. And due to the fact that the budget is not infinite, you can prioritize in such a way that the best value will be generated in the most effective and efficient fashion. This type of work, especially in complex environment, and I spoke about the incremental Tara and the agile environment, need to work hand in hand. So this is something that needs to be part of the process, part of the R&D. Otherwise, you will create a conflict. Regulation requires continual compliance, even after the vehicle is on the road. So to make this happen, we need to make sure that ahead of time R&D have the information, and the aftermarket, the VSOC follows, and this is one single source of truth. So if there is an event, it is conveyed to R&D, very effective and very efficient. This concept will ensure the customer success and will reduce the work and any overload that might be caused. Obviously, the costs are going to go down. We will need fewer human resources, and those human resources will focus on enhancing functionality, not on fixing bugs. The risks will be better managed. Keep in mind that you do not consume risks, you manage and minimize risks. And even in the case of an event, you will be able to remediate and react to it in a more effective fashion. Thank you for your time. If there are any questions, this is a good time to pop them in. If not, then thank you very much for your attention and hope to see you in a near webinar on a new subject. Thank you.